But now let's do the next example, that is example 19.2. okay, that is f of x is equal to x plus 1 by x. So using first principle of derivative. Okay, so okay, now let's write the what is the formula for the first derivative, that is f dash of x is equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, so this is it, the formula for the first principle. We see f of x, see f of x is equal to x plus 1 by x. Okay, we can solve it using this, but let's simplify it to be a little easier. So we can write this as, if you take the LCM, it will be x and 1x times x into x squared plus 1. So we'll just have a normal numerator denominator form. Okay, so we'll do it using this form. Okay, so f dash of x, now f of x is in this form, x squared plus 1 on x. We can do it using this form also, but this will be a little bit easier. Okay, I feel in that. Now f dash of x will be, now putting our function in this in the formula, and now we have to add all or replace x with x plus h. Okay, all the x's. So this will be x plus h whole square plus 1 upon x plus h minus, so this part is over, so minus the function as it is, that is x squared plus 1 upon x. Okay, now let this be in braces because we have negative here. Okay, so now and limit h tends to 0. Okay, let this be like this upon h. Okay, let's bring this h here out. Okay, so it be f dash of x is equal to limit h tends to 0, this will be 1 upon h. Now if you take LCM of this, it will become x plus h and multiplied by x. Okay, so this multiplied by x will be, so x in multiplied this. Okay, so this, let's expand this. This is in the a plus b whole square form, so x square plus h square plus 2xh and plus 1, now multiplied by this x also. Okay, and minus, so now here you have x square plus 1 x plus h times, okay, x plus h, that's it. So we have limit h tends to 0, 1 upon h. Now if we multiply this x inward, it become x cube plus xh square plus 2x square h plus x minus, let's multiply this also. Okay, this will be x cube plus x square h plus x, 1 into h will be h. Okay, whole upon x plus h multiplied by x. Okay, now let's open the braces, and then so the negative sign will be multiplied inside. Okay, so limit h tends to 0, 1 upon h, this as it is. Okay, x cube plus x h square plus 2x square h plus x minus x cube. Okay, so minus x square h minus x minus h. Okay, whole upon x plus h multiplied by x. Now if you see x cube, positive x cube and negative x cube. Okay, it goes, now what we have positive x and negative x. Okay, x square 2x square x h square. Okay, now let's the write the remaining. Okay, limit h tends to 0, 1 upon h. We have x h square plus 2 x square h minus x square h and minus x h, okay, upon x plus h multiplied by x. Okay, now you see we have x square h and x square h. This is 2x square h and this is minus 1x square h. Okay, so it will get subtracted and we get limit h tends to 0, 1 upon h, this as it is, plus we have 1x square h. Okay, so minus h, 2x square h minus x square h will be x square h, then minus h upon x plus h multiplied by x. So in the numerator, if you take the h common, you will have, okay, we'll write it here, limit h tends to 0, 1 upon h. So if you take h common, h, it will be x h plus x square, x h plus x square, and h goes out, minus 1, okay, upon x plus h multiplied by x. Okay, now you see this h and this h goes, okay, so it becomes limit h tends to 0, xh plus x minus 1 upon x plus h. I think this is, sorry, this is x squared. Okay, yeah, this is x squared. Okay, x squared, okay. Now, okay, that's it. Now putting the value of h, we'll have x into 0 plus x square minus 1 upon x, okay, x plus 0 by x. So this will be, x into 0 will be 0, so x square minus 1 upon x plus 0 will be x, and x into x will be x squared. Okay, that's it. And this can again be simplified as x square upon x square minus 1 by x square. Okay, splitting this denominator to both the numerators. So this will be x square will go, this will be 1 minus 1 by x squared. Okay, so this is the answer. So now let's do this using the power rule method also, that is d by dx of x raised to n is equal to n into x raised to n minus 1 formula. Okay, so the function f of x is equal to, let's take it y is equal to, okay, y is equal to x plus 1 upon x. Okay, so here you see this is in this, okay, so dy by dx is equal to d by dx of x plus 1 by x. Okay, so d by dx of x plus d by dx of 1 upon x. Now here this will be, the derivative of x will be 1 plus, see, this can be done using u by v method, or simply just take the x to the numerator. Okay, so see, the power of x is 1, so when it goes into the numerator it become negative 1, that is d by dx of x raised to minus 1. Okay, now this is in the form x raised to n. Okay, x raised to minus 1 is in this is in this form, so we can expand it this way, n into n minus 1. So 1 plus, this will be n into, okay, n into x raised to n minus 1, that is minus 1 minus 1. Okay, n minus 1. So 1, this will be negative 1, so this will be negative 1, negative 1 will be negative 2. Okay, x raised to minus 2. Okay, 1 into this will be 1 minus x raised to 2, so this is multiplied. So now we see, again let's bring back this to the denominator, so it will be 1 minus 1 upon x square. Again the negative 2 will become positive 2. Okay, so that's it. This is the answer we got using the first principle also. Okay, So that's it.